Hello friends, today let's solve the cheapest flights within K-stops problem. There are n cities connected by m flights. Each flight starts from city U and arrives at V with a price W. Now given all the cities and flights together with starting city source and the destination DST, your task is to find the cheapest price from source to destination with up to k stops. If there is no such route, output a -1. So let's see this example. If given n equals to 3, the ages is 0, 1, 100, 1, 2, 100, 0, 2, 500, and the source city is 0, and destination city is 2, and the k is 1. That means we can stop at most once, excluding the source city and the destination city. So we can have at most one another city between these two cities. So that means we can either choose go from 0 to 1 and go from 1 to 2, or we directly go from 0 to 2. But as 100 plus 100 is less than 500, so we will just return this 200. But in this example, we can at most stop 0 times. So that means we cannot stop between the two cities. So we can only go this way. We go from 0 to 2. So we just return 500. And you should know that the number of the nodes n will be in range 1 to 100. That means the data size is very small. So we can use array to represent the graphs. We are given the flights and they are represented as age lists. We can use another way to represent the graph. We can either use agency matrix or agency list. In this problem, the data size is very small, so we can use agency matrix. Okay, and actually this problem asks us to find the minimum price or minimum path from source to another node. If it is unweighted, we can use breadth search, but it's weighted, so we can use Dijkstra's algorithm. Let's see how to use this algorithm. Actually, the difference between the solution of this problem to the standard Dijkstra's algorithm is that there has a constraint that we can at most stop k times between two cities. So first thing first, we need to represent the graph, use agency matrix, and for the 3 given ages, we will get the G0, 1 equal to 100. That means the price go from 0 to 1 is 100, and the price go from 0 to 2 is 500, and the price go from 1 to 2 is 100. And you still remember that we will use a heap when we do the Dijkstra's algorithm. And in this problem, we will also sort by the price, but we do not need the distance array because we only need to find the price to one node. So we can accumulate this price. We first offer the 0, 0, 3. You may wonder why we use 3 other than 2, because that means how many stops we remain. And the given case, the stops between the source and destination. And here, this means how many stops we can reach, and this means they are left. So it should +1, because in this example, if k equal to 2, we can stop twice, at most twice in between. But actually, we can at most stop 3 times to reach the end. Okay, so we will put this is the price 0 and the source place, and we can still go 3 times. And then we offer it into the heap and we pull it. Now the current place is 0. We will see its neighbors will be 1 and 2. And then we will accumulate this price and offer that into the heap. Then we get 100, then 1, that is 2, because we should minus 1. Currently we can stop twice at most. And we save the 500, and that will be 2, and it's still 2. And now we pull one edge from the heap, because this 100 less than 500, so current edge is this one. Let's see what's the neighbor of this one. That will be 2. So we'll accumulate this 100. We'll offer this 200 to 1 into the heap, because this is 2, so we should minus 1, so that should be 1. And currently there is 2 edges in the heap. Then we will pull out this edge. And as you see, currently these 2 equal to the destination city. So that this 200 will be our result. As once we reach the destination city, we return. So it is guaranteed to be the minimum price. And if we cannot reach the destination city, we just return -1. So we also need to make sure that the remain stops is greater than 0. Then we can offer its neighbor cities in the heap. So now let's write the code. We first make a graph. There will be n, and for every flight in the flights F0, F1 will be F2. Then we will use a priority queue, int array, heap new priority queue. That will be AB. Sorry, this is B. And there will be A0 minus B0. So we first offer the new, there will be price 0 source, and there will be K plus 1. So while this heap is not empty, we will pull an array, heap pull. And we know the first item is a price, and we will accumulate that. There will be current 0. And the second item is a place, current place. And the third item will be the remain stops. There will be cur2. So once the place equal to the destination, we just return this price. Otherwise, if the main stops greater than 0, then we can try to find its neighbor, I less than n I plus plus. If the G place I greater than 0, that means they have a flight. We will offer new, the first item will be the price. So the price will be price plus G place I, and the place will be I, and the remain stops will -1. So finally return -1. Okay, thank you for watching. See you next time.